So we just finished looking at optimizing perimeter and area of a shape. Okay? And usually what we want to do is we want to minimize perimeter, okay? And we want to increase the area. Okay? Now in this situation, it's very similar. Okay? If we want to optimize volume and surface area, okay? Usually what we want to minimize is whatever will increase cost. Okay? So surface area is what we want to, this is the one we usually want to minimize. Okay, we want to minimize surface area, and that's because surface area is how much area, okay, a three-dimensional figure will have, and usually we want to minimize the cost. We don't want to have to use as much material, and usually we want to maximize volume, because that's how much a container can actually hold. Remember, volume is how much liquid a container can hold. So usually we want it to be as big as possible, while reducing the amount of materials that we had to use to make it. Very similar to how we optimize perimeter and area. Okay? So this example is going to be might be a little bit challenging. Okay, we want to look at the relationship between volume and surface area and how we're going to end up with this maximized volume with this minimized surface area. Okay, so I'm going to do this with you. Okay, and you can always just come back to this and use the formulas that we're going to go through in this example. And if you have any questions about it, let me know. It might get a little confusing. So finding a maximum for a volume, okay? So Josh has 40 meters squared of plastic sheeting to build a greenhouse in the shape of a square-based prism. So we have a square-based prism. We know that's what he wants, and we have been given an amount of materials that he has. So he's 40 meters squared of plastic. So that means it's going to have all of the surface area of this object has to add up to 40 meters squared. Okay? What are the dimensions of the box that will provide the maximum volume, assuming that he must cover all 6 sides? So in other words, there's no open top. It's not like a bucket. Okay? He needs to cover all 6 sides with this sheeting, and he only has 40 meters squared of it. So we want to optimize this volume. So first of all, it's easier to think about this shape in terms of a net. Okay? We call this a net. I think you've seen them before, probably. This net gives us something we can look at other than just this three-dimensional shape. Okay, so now we have each side laid out, and here's the top, here's the bottom, and all 4 sides that would wrap around the shape. Okay, if you can't picture that, grab a cereal box and rip it open. Okay, and it will kind of end up looking similar to the way this does. So we know that this is S. Okay, we have a square-based prism. So if this is S, this is S. The area of this is S squared. And the area of this will be S multiplied by the height of the object. So this area will be S times H. And that'll come in handy when we have to figure out our surface area. So what we want to do right now is write an equation relating the value, okay, of the side S to the volume of the prism. So this is where things get a little bit tricky, okay? So we know volume is always the area of the base, which in this case the base is a square of S squared. So it's always the area of the base multiplied by the height, okay? So it's always our volume formula. So far so good. But this doesn't relate volume to just S. This is going to relate volume to S and H, and we only want it to be related to S. We want to find out what the relationship between volume and the side of that bottom square is. So that's where our surface area comes in. Okay, let's take a look at the surface area for this shape is going to be, we have 2 S squareds. Okay, so that takes care of this one and this one. And we have 4, 2, 3, 4 of our SHs. One other thing we know, okay, one piece of information that we know for this formula is that we know that our surface area has to be 40 meters squared. So what I can do is I can actually put 40 in for surface area. So this is 2S squared plus 4SH. Okay. So now all I have is a relationship. This formula gives me the relationship between S and H. All I've done is substituted that surface area into it. But if I can rearrange this for h, then that will give me what h is in terms of s. So if you can follow along with that, what I'm going to do is I'm going to, first of all, I'm going to move this. This doesn't have anything to do with h. So I'm going to move this one over to this side. So this side will now be 40 minus 2s squared. 4sh is still over here. Now what I want to do is I want to move this 4s. So I'm going to divide both sides by 4s. Now I have what h is in terms of s. And we can put this back into my formula for volume. Okay. Now what I mean by that is volume is s squared multiplied by the height. But my height is the same thing as 40 minus 2s squared all divided by 4s. Okay. So this is my formula relating volume to the side length s. Okay. So take a second just to make sure you've got all that. We can simplify this. Okay. You can multiply the s squared in. Okay. And if you want to see it simplified, I'll do it quickly over here. Okay. 40 minus 2s squared, 4s. If we multiply the s squared in, like I said, minus 2s to the 4, bottom stays the same. And then divide this by 4s and divide this by 4s. So that would be 40 divided by 4 is 10, s squared divided by s is s. 2 over 4 reduces to 1 over 2, and that cancels out that, one of them, so you're left with 3 of them. Okay, so this is the formula, the simplified version of the formula relating volume to s. Now, what we would normally do is to try and optimize the volume. Okay, we've already taken into consideration that we have 40 meters of material in this formula. So this is actually now a calculus problem. It's like, what do we do to maximize the volume for this one? But since we're not going to do that, we don't know how to do that yet. We're going to use some technology. Okay. Now, using a graphing calculator, we can determine the actual maximum value for volume. So graphing calculators are great. And if you don't have one, you can probably find one online, or you might have a tablet or a phone or some sort of technology that you can access, okay, to be able to graph this, okay, graph this function. But right now what I'm going to do is I'm going to show you how to do it on a TI-83, a Texas Instrument, okay, graphing calculator.